Hello, welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services located in Europe, and I'm going to be your host for today's session. This is a Journey Through the Cloud series webinar, the last of 2015, and today we're going to be looking at digital media workloads running in the AWS cloud. We have one other webinar series that we've run this year called the Masterclass series webinars, and these are a deep dive into specific AWS services where we take an hour and focus on one service for the whole of the session. You can find a link to the recordings from these sessions for this year in the video description if you're watching this on demand on YouTube, or in the links panel, which you can see in the webinar interface if you're joining us live today. Also in the live interface, you can see the materials download panel, the files panel. Here you'll find a PDF of the presentation from today's webinar. Again, you can access that in the video description if you're watching on YouTube. And also in the live interface, you will see a Q&A panel. And if you have any questions at all during today's session about the topic, or actually any AWS related questions at all, if you want to get an answer from our team on, please submit those via that Q&A panel. We'll get to as many as we can at the end of today's session. And those that we don't follow up during the session today, we'll get back to you via email on over the course of the next couple of weeks. So any questions at all, please submit those via the Q&A panel. Also at the end of the session, we'll switch the interface around a little bit and you'll be able to see a feedback panel where you can score today's webinar from 1 to 5. Please give us a rating, with 5 being the best. Let us know how we're doing. And if you've got any qualitative feedback during today's session, you can of course provide this via the Q&A panel as well. We'll accept feedback as well as questions via that panel. So please let us know how we're doing, and most importantly, how we can improve this session for future audiences. So that's a bit of setup and housekeeping. You can contact me, of course, using the details you can see on this first slide. And before we kick off today's session, Digital Media from the Journey Through the Cloud series, I'd like to thank Intel for their support for these webinars throughout the course of 2015. They've been a great help in helping us promote and run the series this year, and with our technology partner Intel, we're presenting these webinars to you for 2015. So, the journey through the cloud. We're looking at common use cases and adoption models here for the AWS cloud, taking a solutions-orientated look at how you can apply different AWS services into a specific use case or business challenge that you might have. Share with you some of the journeys and learnings from other AWS customers that have done similar things before you, and describe to you best practices that can help you bootstrap your projects and increase the chances of success for your projects, of course. And today we are focusing on digital media. So AWS provides a set of secure and on-demand services, including storage, archive, computing, transcoding, streaming, and other application services actually that are relevant to media companies that want to either build new media delivery applications, media processing applications using the AWS cloud, or want to modernize existing applications to improve agility, improve security, and reduce costs. And we're going to take a quick tour of applying AWS to this specific use case during today's session. First of all, we'll take a look at why you might use AWS for these digital media applications. Then we'll look at media ingest, media storage and archive. We'll talk about media content delivery, and then at the end we'll show you some useful resources that you can use to learn more about running digital media applications in the AWS cloud. So let's start off by taking a look at why you might use AWS for these digital media applications. This is a selection of customers that are using AWS today to deliver media applications around the world. And there's quite a broad variety of different use cases that are represented amongst the customers that you can see on this slide. Close to where I'm located here in Europe, got Channel 4 TV in the UK. They started off building their 4OD service, which is now called All 4. It's their on-demand digital service for access to their content. Building this on AWS, and they've added some very advanced analytics capabilities to that service to enable them to improve monetization of their advertising alongside their digital delivery service. RTL in Germany, delivering applications that are second screen apps associated with their broadcast content. They use the elastic features of the AWS cloud to great effect to allow them to scale up their application platform as they're about to broadcast, ensuring that their customers get a good and responsive user experience, and then scale down after broadcast to minimize their costs. SoundCloud, also based in Germany, obviously very large-scale audio ingest and audio delivery platform, uses AWS very substantially. Spotify, with high-quality, very large-scale audio content delivery using AWS. Financial Times, we started here with an analytics workload actually that enables the Financial Times to improve their content targeting algorithms and deliver highly targeted and very specific content to their digital subscribers. And BBC iPlayer, where AWS is in use for large-scale video transcoding, ingesting around about 21 terabytes of video content per day into AWS, the BBC's Media Factory team, and then transcoding this video for play out on all of the different device formats that the BBC's iPlayer is available upon. So pretty broad usage just here in Europe. And obviously we've got media customers around the world, including Netflix, Comcast and others that are also making use of AWS globally. And the core characteristics of the cloud are very valuable here. Zero capex models, ability to scale very largely in the event of high traffic volumes, and to flex the amount of capacity that you have on the basis of the amount of demand that you have at any point in time. The global footprint, high security, and of course the breadth of services that AWS provide are all important characteristics for these customers in selecting AWS to build these digital media applications. So I said a second ago, we have a global footprint with 11 AWS regions around the world. These are geographic locations from which AWS services are delivered and where you can create resources inside AWS for your own applications and services. Distributed, as you can see, globally. We have several more regions that we've already announced upcoming in South Korea, India, Ohio, and here in the UK, which will be implemented during 2016 or early 2017. So this global footprint is important. The regions are coupled with 53 AWS edge locations that we use for delivering a service called CloudFront, which is our global content delivery service, which we'll talk much more about later in today's session. And also our Route 53 global DNS service is delivered in those locations as well. So those are services that you can use to assure good and consistent application performance and good and consistent content delivery performance to customers that might be using your media applications that you've built on the AWS platform. The other thing that I just touched upon a second ago was security, and we appreciate that media delivery and the management of media content assets is a security critical workload. Obviously, unprotected, high quality digital masters of media content are very valuable assets and need to be protected accordingly. And we have a very strong and consistent approach to security at AWS, building on a familiar model of people and process system, network and physical security, a very large and capable security team, and a set of tools that give you visibility into usage and the capability to monitor and audit usage of the resources that you create. I'm going to go into security in much more detail during today's session because we have several other sessions that we've recorded this year, both Journey Through the Cloud and Masterclass series sessions on security. You can find these in the links panel in the webinar interface if you're interested in taking a look at those and learning more about security in the cloud. One thing that is relevant though on compliance is the fact that we have MPAA accreditation for the storage and processing of media content in the AWS cloud. And if you are working with video assets that are relevant to that, you might want to take a look at awsamazon.com/compliance and learn more about that. We also have relevant security accreditations for the storage and processing of personal data, privacy management, and obviously handling payment card details under the PCI DSS security standard as well. You can find much more about these at that same URL, awsamazon.com/compliance. And finally, the services stack that we provide, it's relevant across all stages of the media ingest, storage, processing and delivery lifecycle. I've tried to map relevant AWS services into the different lifecycle phases that are typical in a media workflow on this slide. And we're going to focus on a few of these now in ingest, store and delivery of content as well. We're not going to focus much on processing during this session. We'll touch upon it briefly. I want to focus a little bit more on those other areas in the media workflow or media lifecycle that you typically see. So first of all, on Ingest, how do you get your media content assets into the AWS cloud so that you can work with them or deliver them? And you have several different options here. We're going to cover each of these in detail. So we'll talk about Direct Connect, AWS ImportExport, and the AWS Storage Gateway. But before we do that, I wanted to quickly talk about Amazon S3 multi-part upload. And we're going to cover Amazon S3 in more detail when we come to talk about storage options in a few minutes. But this is relevant as a tool for allowing you, probably the simplest tool actually, for allowing you to ingest media data into the AWS cloud for reliable and durable storage, and then for processing and onward delivery. And the simple storage service, as I said, we'll talk about in more detail in a few minutes, but there's a feature of this service called the multi-part upload. You can find more details on this if you visit the URL at the bottom of this screen. But what it enables you to do in essence is to maximize the rate at which you can transfer data from your location, or where that data happens to be stored, into the AWS cloud. And it does this by breaking up files that you might wish to upload to AWS into a number of separate parts, and then uploading these parts in parallel using request rate optimization, TCP window scaling, and TCP selective acknowledgement. Once you've uploaded all the parts, S3 itself will join those parts together and create an object plus object metadata for the file that you've just transferred. So it can be a very efficient way, and also a very simple way, to transfer large data assets such as media files into Amazon S3 in a very performant fashion. Beyond that, you have a few other options. AWS Direct Connect. So this is a mechanism for establishing a high bandwidth, low latency connection directly from an AWS region to your network or to your data center. So it gives you private connectivity into AWS over a 1 or 10 gigabit physical connection. We have AWS Direct Connect partners that can provide both the BN service to connect from our AWS Direct Connect POP into your network or data center. And many of these partners also provide fractions, so sub 1 gigabit services are available. It uses 802.1q VLANs to enable you to partition up the physical connection into a number of different logical connections, and you can establish differing routing across these logical connections to allow you to connect, for example, to public resources such as Amazon S3 endpoints that we just talked about, or private resources such as those that you might have inside Amazon VPCs or virtual private cloud networks that you've built inside AWS. It offers consistent network performance, and it's compatible with all AWS services, and it's commonly used by media companies for large-scale ingest into AWS, including some of the examples that we touched upon on our references slide at the beginning of today's session. For a transfer service that is more asynchronous in nature, you have a couple of options. Recently introduced the AWS ImportExport Snowball, also known as the Amazon Snowball. This is a physical petabyte scale data transfer solution. You can see on the image on the right hand side here, which is SVP of Amazon Web Services Andy Jassy introducing this service at AWS reInvent 2015 back in October. A physical image, or an image rather, of the physical Snowball device, which you can see on the left of that image, a large ruggedized plastic suitcase really that holds 50 terabytes of storage and includes a high-speed 10 gigabit network connection. And this provides with a secure appliance that you can use to transfer large amounts of data in and out of AWS. We will dispatch this to you. You will then connect it to your network, transfer your data into the device, and dispatch it back to us. And you can find more information about that at awsamazon.com/importexport, or check out the link at the bottom of this slide, and you can watch back the launch video for this particular service from reInvent. See it demonstrated a little bit at the event that we ran earlier this year. We also continued to provide the pre-existing AWS ImportExport service, which has now been renamed AWS ImportExport Disk. And this is similar to the service that we provide with Snowball, but rather than us providing a transportable media device for you to put your data on, use standard eSATA, USB, or internal SATA hard drives or storage devices in the case of USB. You can also use solid-state USB devices, obviously. And you can place your data onto these devices together with a signature file, dispatch those to us using a courier to one of our regional locations where this service is supported, and we will then import the data that's present on those devices after verifying them using your signature file into S3, EBS or Glacier, depending on what you have to transfer and how you configure the particular import-export task that you wish to execute. You can find more details about this, including supported media formats in exhaustive detail, details of how to request an import-export task, as well as the different data transfer targets supported. If you take a look at awsamazon.com/import-export/disk, which is the URL that you can see at the bottom of this slide. We have an additional ingest option which we provide in our own right called AWS Storage Gateway. This provides an on-premises virtual iSCSI storage appliance which you install as a virtual machine inside your own virtual infrastructure, supporting VMware, Hyper-V and other options. And this provides two different types of volumes that will appear locally as iSCSI terminators on your network, block devices of course as a result of them being iSCSI devices. Stored volumes, which are essentially mirrors where you place data into the storage gateway and we mirror that asynchronously into Amazon S3, and you can then turn those stored volumes into snapshots inside AWS and access them from EBS. Okay, and then secondly, cached volumes, which are much larger, up to 32 terabytes in size at the back end per volume. And these volumes are locally cached, so a smaller cache is available locally for frequently accessed data, whilst the volumes are elastic in scale back in the cloud. Once again, you can access data stored in these cached volumes from EC2 instances as well as from your on-premises storage gateway device. Okay, and this provides you a mechanism for moving data into AWS, which can plug in transparently into existing data management workflows that you might have that deal with accessing data locally on block devices on your premises. Now, there are also partner storage gateways available which provide similar functionality, but there is the AWS Storage Gateway available to you as an option as well. You can find out more details on that if you visit the URL that you can see bottom right on this slide. And while we're talking about partner solutions, there are also other partner ingest options. Many of them are available in the AWS Marketplace, which is a service that ISVs, independent software vendors, can use to sell and provide software services to AWS customers via an e-commerce style experience. Selected a couple of relevant partners here, Aspera and Signiant. They both provide high-performance data transfer software solutions for transferring large data assets, often used for media data transfer between on-premises and AWS cloud-based storage infrastructure. So check out the media category listing, which you can find if you click the link at the bottom of this page, or of course you can search directly for Aspera or Signiant in the AWS Marketplace and take a look at these products. There's also an open source option available for moving large-scale data into the AWS cloud using a protocol called Tsunami UDP. We have a blog post from mid-2014 which explains in detail how to set up this open source UDP accelerator for file transfer using an EC2 instance which runs the file transfer agent, and then obviously local to Tsunami UDP clients out on your infrastructure to transfer data in, maximizing utilization of network bandwidth. So you have several different options for transferring data into AWS. If you need help to work out which is the right option for you given your particular usage scenario or use case, I recommend making contact with your AWS account manager or with your AWS solutions architect, and they'll help you through and guide you through the process of selecting the right transfer mechanism for your particular use case. Persisting this data in AWS so that you can work with it for processing or for delivery using media storage and archiving services is what we're going to cover next. And you have several different options here as well. The Amazon Elastic Block Store, these are high performance block storage devices that you're going to attach to EC2 instances, place file systems on, and then work with just like standard disk drives. The Amazon Simple Storage Service, S3, we mentioned it earlier in the context of multi-part upload. It's a highly scalable, highly durable object storage service that's delivered in specific AWS regional locations around the world, so you can specify data sovereignty for the data that you wish to place inside S3. And then an adjacent or associated service called Amazon Glacier, low-cost, long-term object archive. It's roughly 30% of the price of Amazon S3, but there is a asynchronous access period or an asynchronous call that you'll make for access to an archived object inside Glacier, and you've typically got a 3 to 5 hour wait before you can read the first byte of that object after you've requested it. So the trade-off for lower cost is access latency. It can be useful for long-term archive of media if you wish to establish an archive for infrequently accessed media objects that you may need to recall periodically, but you can tolerate that access latency during that recovery process. Let's cover these in a little bit more detail now. So the Elastic Block Store, as I said, high performance I/O block storage attached to Amazon EC2 instances for access. It's like a virtual abstracted disk drive in the cloud essentially. Very good performance. You can predictably scale actually up to 20,000 IOPS per volume now with a specific volume type called the PIOPS volume. And volumes can be up to 16 terabytes in size. And there are areal density limits, so for high levels of IOPS, absolute IOPS per volume, you do have to provision correspondingly large volumes in order to achieve the IOPS levels that you're looking for. We provide automatic replication within an availability zone, so EBS volumes, as we call them, are AZ or availability zone specific. They can only attach to instances in that AZ. But then we provide a point-in-time snapshot capability, which leverages Amazon S3 at the regional level. That enables you to copy snapshots and create new volumes in different availability zones or even across different regions if you wanted to do so. You can control that using the AWS CLI SDKs or API, so you can automate that process of copying snapshots across AZs or regions if you wish using whatever automation tools you wish to develop, or you can use various open source tools that have already been developed to provide that functionality. So that's the EBS Elastic Block Store storage type. S3, as I said, this is a very, very durable, 11.9's durable object store that is created at the regional level. So you'd create an S3 bucket, which is the container that we use to organize the S3 namespace in any individual account. And these buckets are created regionally, so you specify where a bucket will be held. Any objects that you put in that bucket will be kept in that specific region. We provide strong authentication and authorization mechanisms to ensure that data is only accessible to those entities that you specify are permitted to access it. Several different encryption options, including the opportunity for you to encrypt your data client-side using a reference implementation of a client-side encryption library that we provide, or provide us your encryption keys as a one-time activity object upload. We will then encrypt your data and destroy the key or delete the key. So they're ephemeral keys in that case. And then you give us the same encryption key when you do wish to download the object. We will decrypt it and send you the unencrypted object back down to you. Of course, we're using TLS to ensure that data is encrypted in transit. And this encryption key offload, or that encryption offload, is very useful for media where you may need to encode or encrypt rather large files and you don't want to carry that on your own compute cycles. You can use that server-side encryption capability with your own encryption keys with S3 to make that a very simple and lightweight process for you. And within S3 we provide several different storage classes. Standard, which is obviously intended for general purpose use, 11.9's durability. Infrequent access, which is relatively new. This provides a lower price point for storage, but you do pay a retrieval or access charge each time you access an object. It's different to Glacier because the object access will be in milliseconds rather than in several hours, or the time to first byte will be in milliseconds rather than several hours. But you do pay that retrieval charge. That could have use cases in media. And then RRS, which is used extensively by media customers. This is a 4.9's durability, so 99.99% durability. And it's commonly used by media customers that are creating derivative works, for example via transcoding processes, may wish to minimize the cost of storing those derived works because they're recreatable. It's common to place those in RRS. Other than the reduced durability, it's identical to the standard access class in terms of access performance, security and lifecycle management capabilities that you can apply to it. But it does have that reduced durability and a corresponding reduced cost, around about 20% cost reduction if you're using RRS storage in comparison to standard storage. As I said, there are very good and comprehensive security controls around S3. I'm not going to cover this in depth here. I recorded a masterclass series webinar early this year, which is an hour-long deep dive focusing specifically on S3. It's one of the most popular pieces of content that I've created this year, actually. And I would recommend checking that out if you want to learn more about bucket and object level permissions, signed URLs, query string auth, IAM policies as they apply to S3, object versioning and MFA delete. They're all covered in that masterclass series webinar, so you could consider that a bit of homework. I'll also put that in the video description for this video on YouTube as well. I think it's a very useful resource to take a look at if you want a deep dive into S3. Having said that, one thing that wasn't covered in that S3 masterclass video was some of the new logging and auditing features that have been delivered for S3 since that video was recorded. We've always had the second option that you can see on this slide, which is logging of object level operations, where we store S3 server access logs in a separate S3 bucket that you can configure for logging, and you can then analyze and visualize those using either your own or third-party tools. So that's an important security and audit component. But a few months ago, we also added Amazon S3 bucket level operations logging and auditing to AWS CloudTrail. And this allows you to log and audit additional API calls that wouldn't be categorized as object level operations. So things like modifications to access control, changes to lifecycle policies, or changes to cross-region replication settings. These are captured in this new S3 bucket level operations audit log, which you can capture via AWS CloudTrail. Once again, you can store that in a separate S3 bucket, and then you can use partner tools such as this excellent tool from AWS technology partner Sumo Logic to provide, this is actually visualizing those S3 server access logs, but they have a corresponding tool for visualizing CloudTrail audit logs as well. And there are, of course, other technology providers such as Splunk and Loggly that provide similar functionality as well. So if you're interested in this particular solution, this is Sumo Logic, but there are other partner solutions available that have similar functionality also. Beyond S3, you have that additional archiving option that I talked about, Amazon Glacier. This is further reduced in cost, so it's about a third the price of S3 standard storage. There is a 5% of monthly average storage retrieval that you can make for free each month, so you can retrieve up to 5% of your data each month. After this, you'll have in the EU West region, for example, or EU Island region, a 1.1 cent per gigabyte retrieval fee that applies in addition to the storage fees that you will pay for any data that you have stored in your vaults. You have this 3 to 5 hour asynchronous retrieval characteristic. It offers 11 nines of durability in the same way that S3 does, and it also offers encryption, and it has, again, strong authentication and authorization mechanisms to ensure that data is kept securely inside Glacier. And you can also automate the process of lifecycle management. So you can specify lifecycle rules inside Amazon S3, and you can have objects automatically moved into Glacier a specified period after their creation, actually also automatically expired either directly from S3 or expired from Glacier, once again a specified period after creation. And there's more details on that either at the URL on the bottom of this slide or in the S3 Masterclass webinar that I mentioned a little bit earlier. The final topic that we're going to cover in today's session is media content delivery with the AWS Cloud. And there's some obvious benefits of making use for AWS for this particular component of the media workflow. Firstly, the ecosystem. So we touched a little bit already on some of the partner solutions that are available in the AWS marketplace for Ingest. There's also a significant number of streaming technology solutions that are available in that same marketplace from organizations including Wowzer and Adobe, provide media streaming services that can either operate natively on EC2 or integrate and combine with a service called Amazon CloudFront, which we're going to talk about later, the AWS content distribution network service. In addition to that, of course, we have all of the native infrastructure services that we've already touched upon, which you can make use of to create media and transcode media for subsequent streaming operations. There's very good scalability characteristics from using the cloud, as I'm sure you know by now. Pay-as-you-go pricing model, a ton of capacity when you need it and zero capacity when you don't, so you're able to scale your costs in line with usage. And the global footprint that we talked about earlier provides a very scalable platform for media delivery. And then we have some additional media-specific capabilities, both in the services that we provide, which we'll talk about in a second, as well as the MPAA security best practices for media streaming and asset protection, which we talked about at the top of today's session. So what does a streaming pipeline look like on AWS? Well, first of all, you can ingest and store your media assets using the techniques that we've already covered earlier in today's session. And then you can apply transcoding services to the assets that you have stored in Amazon S3 using either the Amazon Elastic Transcoder, which is our own transcoding service, providing a broad range of different format support, as well as some other advanced services, and being tightly integrated, of course, with Amazon S3 itself. And the transcoding process is transparent and automatic. There's no need to administer software, scale hardware, tune performance, or otherwise manage any infrastructure. You simply create those transcoding jobs specifying the location of the source media files that you wish to transcode and how you want them to be transcoded. Then our Elastic Transcoding service provides transcoding presets for popular output formats, which means that you won't have to guess which settings work best on particular devices, and all of those features are available via the Service API, via SDKs, or via the AWS Management Console. So that's the web-based console for Amazon Web Services. In addition to that, of course, you can additionally plug in other transcoding software or services if you wish to do so, and operate over assets that you've previously stored in Amazon S3. So that would be a typical life cycle. Once transcoded, the assets are written out into a specified S3 bucket or prefix and will be stored there. And then you can apply video streaming services to those assets, such as Amazon CloudFront. Now, this is a service that lives, or is delivered rather, from those 53 different edge locations around the world that I described. It's a service that's been iterated over quite some time now. It supports all HTTP-based streaming protocols, specific caching optimizations for video streaming, as well as native streaming for HLS. And as I mentioned a second ago, we have joint solutions with several media streaming ISVs who have products available in the AWS marketplace, whose solutions will integrate with CloudFront to provide both on-demand and live streaming services using this CDN. As you might expect, there are some very robust and capable security controls that are integrated with CloudFront, including the ability to deliver private content only in response to securely signed requests, to perform CloudFront origin access identity authorization. So this allows you to store media assets in Amazon S3 and prevent access from non-CloudFront origins, essentially forcing delivery through CloudFront and therefore allowing you to enforce signed URL verification, geo-IP blocking, or restrict CIDR access blocks to content, so you can perform some of the functions that are required to ensure that you're managing your content in a way which is compliant with, for example, whatever rights you might hold to specific media. We support HTTPS only origin fetches to ensure that data is encrypted in transit, both from origin to CloudFront and then of course from CloudFront out to your requesters, to your end users. And we have a comprehensive access logging capability as well, which I'll return to in a couple of minutes. So there's some excellent tutorials for using CloudFront for media streaming. You can access those at the URL that you can see at the bottom right of this slide. This includes both on-demand streaming tutorials as well as tutorials for live streaming with Amazon CloudFront, as I said earlier, leveraging using services from Wowzer, Adobe and others to support those live streaming events. And the logging that we provide can be used to enable you to monitor and measure the customer experience for content that is delivered via CloudFront. Here you can see again another example of a visualization. This one is also from the Sumo Logic tool, but there are both open source and other commercial partner tools available that will enable you to do customer experience monitoring for content delivered via CloudFront using CloudFront access logs, which are deposited in an Amazon S3 bucket, and you can then process. You can also write your own processing logic using services such as Amazon's EMR service or our Redshift data warehousing service, depending upon the scale of the log files that you wish to process. And again, if you have queries about which is the right solution there, Redshift or EMR, then please make contact with us, and one of our solutions architects will be able to help you out with that decision process. Okay, so that concludes our quick tour of applying AWS services to digital media use cases. As usual, we're going to close up with a few resources that you can use to learn more about this particular topic area. If you do have any questions that have arisen in your mind as a result of watching the session today, please submit those via the Q&A panel in the webinar interface if you're watching us live. We'll return and answer a few of those questions at the end of the session after we've taken a very quick look at these resources. So the first important resource is the AWS Digital Media Solutions Center. You can find that at aws.amazon.com/digital-media. And this includes many of the customer references that we've talked about briefly during today's session in a lot more detail, as well as a lot more detail about solutions and AWS services that are relevant to this specific use case, as well as some excellent recorded sessions from AWS reInvent 2015, delivered both by AWS media experts, as well as by some of our larger and more prominent media customers that agreed to speak at that conference, and hopefully we'll share some good practice with you if you watch those videos and help you accelerate your own media application development with AWS. There's a comprehensive list of digital media customer references, as I mentioned earlier. If you follow the second URL that you can see on this slide, you'll find around about 30 to 40 different media references, including details on all of the customers that I talked about at the top of the session, as well as a stack of others. And then lastly, if you visit the Solutions Center, the bottom slide that you can see here, there's a lot more depth there on solutions for ingest, for transcoding, for media workflow management, for content delivery, and for other aspects of the media lifecycle that you may want to implement on the AWS cloud. So some really good resources available. I encourage you to check all of those out if you're interested in learning more about this particular topic area. For general architecture guidance on AWS, of course, including several media-specific architectural patterns, visit aws.amazon.com/architecture. And we also have a comprehensive set of training offerings that you may find useful. These are collected at aws.amazon.com/training. You can find more details on certification, our formal education program, including classroom and online training, as well as details of our self-paced labs offering collected together there. So that concludes all the content that we have for today's session. If you want to stay up to date with AWS here in the UK and Ireland, you can find us on Twitter at AWS_UKI. And AWS Cloud, also on Twitter, is a great source for information about new AWS services, new case studies, how-to guides, and lots of other good quality, very helpful AWS-related content. So do follow us on Twitter. It's worth creating a Twitter account to follow us. Such good resources. And of course, you can find me on Twitter also at Ian. Last thing I want to do is just thank you for joining today's session. Do appreciate you giving up some of your time to learn a little bit more about AWS and about our services. And if you joined us for any more webinars this year, earlier in the year, thanks for being a returning viewer, joining us for today's session. Of course, you can find all of our sessions from 2015 recorded and available on YouTube, and all of our slides collected together and available on the AWS SlideShare. You can find links to both of those in the links panel in the webinar interface that you can see. So that concludes our program for 2015. Thanks for joining us. We're going to turn now and take a few of the questions that have been submitted during today's session. Thank you.